Let's now take a look at the Syslog implementation, but before doing so we just wanted to show you one other way you can run bash shell scripts using cron, and that is to prefix the shell script with the source command or dot. That's nano etc cron tab, the general system-wide cron file, and this is on the remote server. We need to do it locally. And for example, for the ping test, if you prefix the shell script with a dot, that means to source it, or the keyword source. Either or will ensure that the command runs successfully. Ditto for the remote user student1. Let's sun as student1, and then cron tab E, which takes us into VI. We'll re-execute export, then cron tab E again, and change this to source. And we'll check up on the cron item throughout the rest of our studies. So with that said, we need to look at Syslog. Syslog handles logging. And it does so by supporting two facilities, or two protocols: Unix domain sockets via the dev log interface, as well as internet sockets using the UDP protocol, port 514 to be specific. So it handles all of the logging on the system. There is a subsystem, klogd, or kernel logger, which is used exclusively by the kernel to log. But apart from that, the programs on the system will log through Syslog, unless of course the program has its own logging facility, such as Apache and others. But by and large, logging is handled through Syslog. Syslog is implemented on this particular box in Redhat Enterprise 5 as the sysklogd package. And we can find out more information about the package using the RPM utility locally. And the version will be returned once RPM queries its database of packages. So this is the package. Let's RPM queryless sysklogd. And here are the important items. Since Syslog is responsible for logging information from multiple programs, it has a log rotate entry in the etc logrotate.d entry file, or directory that is. There's a file in there which contains the rules for log rotation. In the next section we look at log rotation, where we'll study this file to see the directives that have been specified. When the system is booted, Syslog starts via the initialization script, syslog, and there's a sysconfig item that you can edit to turn on or off various settings, including the ability to bind to UDP. The primary configuration file, however, is located in etc, and it's called syslog.conf. This file contains the various rules that Syslog uses to route information to different files. There's also the klogd component, which we mentioned, which is used by the kernel to log, exclusively of syslogd, the main binary used to log information, as well as documentation. So the main binary is syslogd. It reads etc syslog.conf. Optional startup information is placed in etc sysconfig syslog. An initialization entry is in init.d, and a log rotate entry is in the logrotate.d directory. So Syslog logs daemon information, but how exactly does it do so? Well, we'll get into that in a second. Let's just list one of the other features. That is the ability to log to local and remote targets. By default, Syslog logs locally to a file usually beneath the var log directory tree, but can optionally log to a remote host running Syslog. using internet sockets. So now back to the primary configuration file, the rules file, etc.syslog.conf. This is the primary file where you spend most of your time. Now we're going to focus on the remote server's syslog.conf file because it's pristine. The local server has entries from previous studies. A brief look at syslog.conf will reveal as such. The default settings are in, but we've also got a rule for Linux CBT Deb 2 from our Debian training and other items. So to take advantage of a fresh Red Hat Enterprise 5 syslog configuration file, we're going to work on Linux CBT Serve 4. So let's sun and then nano etc syslog.conf. It's installed by default. Hash marks indicate comments when they begin a line, so this kernel entry is commented. As we've mentioned, kernel logging is handled by the klogd daemon, so there's no need to turn on the facility here unless you need additional information routed elsewhere, apart from the standard kernel output locations. Now, a standard syslog file consists of rules and targets. On the left-hand side, you find rules, one or more. The right-hand side, you find targets. So standard syslog.conf file contains rules and targets. But rules can be further broken down into separate components. And they include the following: facilities and levels. This is the main routing capability of syslog. Syslog is able to route messages based on facilities and levels. Facilities are tied to applications and or daemons. So we'll just indicate by specifying an arrow that it's tied to application/daemon/network device, etc. So a given device, application, or daemon is going to report its information using a facility. A facility provides the general way to route information. All facilities share a set number of levels in common, and they vary the level of severity of the message. So levels correspond to levels of importance, or importance of message. And the importance level ranges from 0 through 7, with 0 meaning debug and 7 meaning emergency. So let's list those levels. Beginning at 7 for an emergency message, followed by 6 for alert messages, which are not as critical as emergency messages, but generally indicates a level of criticality that's worth exploration. The 5th level is critical, followed by error, then warning, notice, informational, and last but not least, debug. So from the perspective of syslog and syslog supported applications, they'll use a facility followed by one or more levels. And by one or more, we mean the following. The lower the level number, such as 0 for debug, the more information. So let's just indicate more information. However, as you go up to higher levels, less information. But this does not say that the debug level is more important than the emergency level. Quite the contrary. When you receive emergency or higher level messages, they're more important than general debug level messages. And when configuring syslog, you should be sure to specify a meaningful level so you don't end up with superfluous information. So for example, it's unideal to log at the debug level unless you're truly debugging. It may be more ideal to log at info, notice, or warning and suppress as a result the amount of information that you receive. Now, again, the lower the level that you indicate to log, the more information you'll receive. If you log at debug, you'll receive all messages info and higher. If you log at info, you'll receive all messages info and higher, and right up the chain up to emergency. So if you log at the critical level, you will not see error down to debug, but will see critical up to emergency. And that's how syslog facilities work. So with that said, let's discuss targets. Targets tend to be the following: file, such as